queued up. We have some lecture stuff here. And so we'll start out with the revised course schedule. So I mentioned this for assignment 3 that that I was very late in terms of updating the due date. I've mentioned in other lectures and in just the general cadence of the course that assignments are due every 2 weeks, but but I didn't have the assignment updated. So I had mentioned on the announcement that I was giving everyone an extension until today. Anyone on the call who still had issues getting it in on time, and perhaps I could try to find a less spoilery way of going through the homework. So yeah, unless one of you people mentions in the chat that you weren't able to do it, I'll just assume everyone on the call did it, and I'll be a bit lenient with anyone who may have sent that in a couple of days late or so. But for the rest of the assignments, the due dates are set, and as I mentioned in the beginning of the class that we had an extra meetup this semester, and it was just due to the day of the week that we're having these meetups. We're missing Rosh Hashanah and I believe Yom Kippur. Like we missed a couple of the Jewish holidays, I believe, and there was something else that like usually we have at least one meetup that we skip. So I stagger the assignments accordingly. But in this case, since we have all meetups, I added a module I'm calling module 4.5. It's meant to be something that it's a simpler assignment. It's meant to sort of give everyone practice with using Flask, and it's meant to really just give students exposure to this. And I'll open up I won't go too much into it, but looking at module 4.5, there's, so you could see kind of a sample Flask app here in the notebook. You'll see or in the PDF rather, you'll see like a few recommended blog posts. And the goal of this is to just give everyone some extra time in, and by the way, everyone could see my screen, I assume, so mention in chat if you're not able to. But the point of this mini assignment is meant to give, just have people think a bit more about what sorts of things you need to think of when designing a web app using JavaScript, and in particular D3. So when you're using tools like Shiny and Dash, a lot of you have separate files or separate objects for UI and server. You have separate functions in terms of Dash, depending on whether you're using callbacks or the layout, which divides pretty easily into a client-server sort of relationship. But in actuality, with these sorts of tools, you're not sort of really thinking of when is a call going to the server, how exactly is that happening? And with something like D3, you need to think a bit more about what about how you're using something like that. And why I thought this was interesting is because if anyone for their final projects, like you have the choice of using Shiny, Dash, or D3 for your final projects, which I'll also mention in terms of scheduling. So you have your choice of what to use. If you do choose JavaScript, using something like Flask really allows you to it really plays nicely with D3, because one of the challenges of using JavaScript is JavaScript isn't the best at all at data munging. It's first and foremost a web language. It's not meant to do real data analytics. So there's no, you're not going to have data frames there. You're dealing with sort of different types, weird types of data structures. It may seem very clunky. A lot of times it is. And using something like Flask is a really cool workaround that lets you leverage the power of something like Python. So just looking at the example apps here, and I won't get too far into this at all, but basically this is essentially allowing you to pass variables into your API. So I could, in this case, like I'm sort of including in the notes, replace, try going to your API/foo. You'll see that that variable is getting passed in. Change foo to any other word. It'll also get sent in there. And this is very useful because you could have some data munching being done in Python. You could have you could have sort of complex filtering, some reaching out to multiple databases and APIs, do all of that in Python, and then using d3.json, which we'll talk about when we get into JavaScript, you're able to essentially read the results of what you're doing in Python. So it's a good way of beginning to develop D3 style apps. So with that, and if anyone has any questions, just put it in the chat. And if no one else does, I'll just quickly highlight the revised course schedule. So so right now it's October 10th. We're going to be going over module 3, and the rest of oh my God, did I already make a, no, yeah, that is correct. Okay, so it's staggered every 2 weeks, and October 21st will be the next when the next assignment is due. Module 4.5. This is a mini assignment, so that's going to be due on November 4th. But the final project proposal is also going to be due on November 4th. So I suggest using that extra time to really get thinking on what you want to do with your final project. So going to what we have in here, so I'll just go into the final project proposal. There's a link to this in the content page for week 4, or for module 4 rather. So and actually it's in module 4.5 because that's the module that we're working with. So you can see your final project proposal. That's going to be due on November 4th, along with assignment 4.5. So for the final project proposal, it's and this is something that everyone should really start thinking of, even though the end of the course seems a long way off. It's and I'll switch that date. Even though the final project seems a long way off, it's worth half of your grade. So I definitely recommend putting as much time as possible into thinking about what you would like to do. And the sort of where to get started is just simply keeping an eye out for for data sets that you may think would make an interesting fun project or an interesting final project. Something that definitely don't be afraid of picking something that's within either your sort of area of expertise, or absolutely something that's that you're interested in. If it's sort of a government data set or different organizational data set that is something you feel passionate about, that's definitely something that comes through with a lot of the final projects. And yep, Peter Lombardo mentioned baseball. So if you want to give a hand at Moneyball, you could definitely try that out and see what you could do there. So I technically mentioned like it should be relevant to current policy, business, and justice issue, but I I consider that pretty broad. So if you want to like don't be afraid of not like if the data set is really interesting, then write the proposal for it, and odds are it'll work for the final project. Really, the things that I focus on, and for the proposals, I really try to give as much feedback as possible, because I think of this as really part of the final project is the discussion over sort of I don't want to just sort of leave everyone on their own for the final projects. I want there to be a dialogue and to have an idea of making sure everyone's on track. And so a lot of the things that I'll mention in my feedback will be things like, if I see a data set and it seems like an unwieldy data set, or it seems like perhaps the questions that you're asking of the data need to, really require fleshing out. These are the sorts of things that I'll mention, within the first week after receiving the proposals, because I want to make sure that everyone is on track to create successful final projects. So, and for those who have looked ahead in the GitHub, assignment 6 is also going to be in service of the final project. So, basically you can almost think of the final project as happening in 3 steps. You have the, first step, which is the proposal, and then the feedback. The feedback is usually going to be, in most cases, it's going to be pretty much me directly saying, do this, do X for assignment 6. So just, definitely take that in mind for assignment 6. And then the last part, obviously, being the final project itself. And there's going to be in terms of scheduling for that, there's going to be the final project is technically due on the Friday, December 21st, but and the meetup is on December 19th. But I'm really, 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 really heavily suggesting that you have your final projects 99% done by December 19th. That should be your final project, and really the only things that you should be doing with those last 2 days are taking into account feedback that you either get from your students or from me during the meetup day. So really things should be done by that end date. So any questions on the newly revised schedule? Hope everything makes sense, and hopefully things are spaced out a bit more evenly, and you guys will get some interesting exposure to Flask by having a little mini assignment. Cool. So with that, I'll move on to the end. And these are still, so for homework 3, I still have a separate UI and server, because I pretty much seconds before before this began, my drive was giving me issues all day. So, but this will still run. That I made sure of. And we'll begin talking about this assignment. So for what I did, I ended up just creating one app and separating the 2 questions with tabs. I really any sort of either 2 separate apps or any other way that you guys ended up submitting this is fine. Really it just comes down to what's happening within each individual question. So let's go back to our GitHub here, and I'll go to the PDF so we could take a look at the questions. So the data that we're looking at is from the CDC Wonder dataset. And I believe I had a global, I did have a global.r. So I'll just bring in my data so we could, or I'll stop this, bring in the data. And so we'll just check out the data before we get started. So we have a few columns here. We have a few categories. We have data by state, by year. So there's a time series element to this. And we have a collection of these ICD chapters. So if I just look at the unique what did I do? ICD. Oh, that's weird. I should not be naming data frames. Ah, thanks. Thanks, Joel. Joel mentioned I was spelling ICE instead of ICD. Um, so typos are the horror of live WebExes like this. But so here we just have the collection of diseases that we're looking at, and in terms of the rest of the data, we just have all of our states, and then we have a few numeric variables. So we have death, population, and crude death rate. So we're able to, so with that, we could get an idea of what we're looking at with these two questions. So first, we're looking to compare mortality rates from particular causes across different states. And so I mentioned we're looking at 2010 only. So we're not really focusing on what's happening over time. We're sort of taking just a slice of time, and we want to be able to see the crude mortality rate across all states from individual causes. So, as a researcher, I want to be able to look at each of these causes and, try to get an idea of what the, distribution across all states is for an individual year. And if I run my app, so for this first question, it's a pretty, these questions, like this was really meant to just have everyone get a handle on Shiny. So there, it was, a bit clearer in terms of what's being asked for. So, something like this, it's, we're ranking states. So that tells you that, you want to some sort of interactivity where you're viewing all states at once. We're looking at a specific year. And also the fact that we're looking across all states, that should give people additional clues that we're really looking for something comparative. And that's not where we should focus our interactivity, because you want to be able to sort of compare it at one go. And then being able to select from one cause at a time. And so with that sort of like if you think about what sort of strategy would really help with something like this, you're looking at the diseases one at a time. We're looking at a comparison of different states. And so for the first question, while I do have two drop downs here, state isn't controlling this. That's only coming into play for question 2. But for question 1, we're looking at the ICD chapter. That's the real focus of what we're looking at. So here I ended up sort of using a strategy we sort of saw before, a Cleveland dot plot, and being able to, in this case, because we had so many states, I thought it was best to rely on hover interactivity to really to sort of get to sort of tell us what states we're looking at, rather than try to squeeze everything on onto an axis. And Dan W. mentioned that he didn't interpret across all states. That's so. Dan, were you able? Were you able to? Were you comparing across time, or was it just sort of an individual data point, and users were filtering by ICD chapter and by state? And Dan also, so you could put that in the chat if you're not able to get your headset working. And in terms of hover, in terms of hover in Shiny, I didn't want to get too deep into this. There are ways. So basically, the only the only thing that is giving me hover in this app is the fact that I'm using Plotly rather than ggplot. So in the sample code, you guys saw, there were a few different graphing packages that would, that you could use with Shiny. So Plotly totally works there. ggviz, Google Viz works. A lot of different packages. Just ggplot is totally usable. Yeah, sorry, Dan. We weren't hearing you. We weren't hearing you at all, really. So if you're able to get it to work, we could talk, but otherwise I'll glean what I can from the chat. So it was by state, and were you comparing the different ICD chapters? So you would be able to pick a state and see sort of what's changeable, but it was also changeable by ICD chapter. Okay. So yeah, I'd have to see exactly how that was implemented. It's basically, in terms like one of the things that I wanted people to focus on for this project was sort of relating the general the sort of general like concepts of data visualization that we've been talking about in the discussion forums, and sort of try to put into practice what we've been talking about there. So something like this, it's you could almost think of this as an extension of maximizing your data to ink ratio. So whereas it just sort of gives you alternative places to really hide your ink, essentially. So something like this, if we were talking about static graphs, we're talking about including all states. We need to have a tick mark for each state. And there are a few strategies that we could pick for something like the Cleveland dot plot, for example. I would think it's pretty useful to sort of label the dots on like sort of have annotations right next to the dots themselves, because that gives you a bit more space rather than having to rely on a y-axis to display all states, which is pretty unwieldy. But what interactivity really allows us to do is to essentially hide that bit of ink. And it's a trade-off, because with something like this, we're giving up the just automatic comparison. So we're not able to, without hovering over, know where West Virginia is versus California. But the sort of it is a trade-off, and the upside is it's just that much of a cleaner visualization. So perhaps one thing that one could do here is be sparse with the labels. So perhaps label the state with the highest and the state with the lowest crude death rates, for example. That's one strategy in terms of getting some information that users would be able to sort of see right at the outset. And to get back to the specific question that Dan asked about hovering in, using hovering action in Shiny. There are ways of doing that with Plotly. So actually, if I believe it would just be Plotly. I'm usually so good at knowing these off the top of my head. So so you're able to like, and you could see here, you're able to like actually use hover events. But with something like Shiny, I think it's best to really to like to focus more on what, in my opinion, Shiny does really well. Like Shiny is really good at having sort of ready-made UI elements. It's really good at providing you the sorts of interactivity, sort of interactive widgets that you would need, and so like I wasn't focusing too much on really having to what's called cross filtering. So imagine hovering over over this and getting so rather than having a drop down here, being able to hover over this and get another graph that shows a time series for that state, for example. You're definitely able to do that with Shiny, but I didn't want to kind of focus on too much with Shiny and sort of bring that up when we're talking Dash. But I'd recommend checking the the sort of R and Shiny pages, and this will go into different strategies to having dealing with sort of these styles of interactivity. But in terms of just having an interactive graph, it's as easy as using Plotly and then using render Plotly rather than ggplot and render ggplot. So that's so that should be it for question one. So question one, it's fairly straightforward. We're just picking, we're picking our diseases. We're able to see the, compare across states the crude death rate, and really the sorts of things that I wanted everyone to key into with these sorts of questions is to really think about, like, when you are comparing across states, what does that mean when you have the option for interactivity? What does it mean when you have the option to add a drop down and have users explore explore the data in that way? And Vikas asked in the chat, is ggplot designed to be an easy replacement slash alternative for, or is Plotly designed to be an easy replacement slash alternative for ggplot2? It definitely is. It's and Plotly is really meant to be sort of giving users in R and Python the ability to get interactive visualization. So we actually have, and I didn't really focus on this because I didn't want too many avenues for. There's lots of different ways to use Plotly. So in a lot of ways, I wanted to try to streamline that experience for everyone. But we have a wrapper that is called ggplotly, and you're able to pretty much use the grammar of graphics in almost the exact same way that it takes ggplot objects and it ends up showing so actually let's see where the page is. Yeah, so here you'll see a lot of different examples of pretty much making ggplot objects and then just running them through this ggplotly command. So you don't even really have to think about the change in syntax. You're just using Plotly as an API to make that ggplot interactive. So getting to the second question, the second question is looking at things in a slightly different way. So right now, we're looking at are states improving their mortality rate per cause faster than or slower than the national average. And in this question, there's a bit more going on. There's basically, the comparison with the national average. So that's something that everyone needs to end up calculating. So, looking here, and you can see I'm using this, selected data. I'm using some reactivity here, and I believe. So that was right here. I'm calculating the national average and, just allowing us to use that whenever, whenever we're making these comparisons by state. So, because we're looking at time, line graphs are the best to really show that change over time, and showing, two scales like this, we're looking at a rate change. So we're assured that they're comparable. So we're fine with just showing two lines on top of each other like this. And we're able to look at different states and get the different comparisons here. So looking at the US average as well as whatever state we're looking at. So you're able to find out things like, with New York, it's a bit more variable. You're getting sort of higher changes and lower, higher increases, lower decreases when compared to national trends. In this case, looking at pregnancy. But in general, really what this is asking us is, like the sorts of questions you need to ask yourself in general when you're thinking of interactivity is, what makes sense to add it as a drop down, as a range slider, etc. What makes sense to, display all at once. Some of the common themes is just because you have access to drop downs and things like that doesn't mean that you don't want to show things on a single graph. Sometimes you want users to be able to make their comparisons at one time. And, so that's one thing to think of. And, in line with what we've been talking about in the discussions, these, I think it's useful to sort of think of all of this in the context of the sort of classic data visualization concepts. So we are still maximizing the data to ink ratio, but what does that mean when we have the ability to add drop downs, tabs, things like that? What exactly really changes when we're able to do something like that? If we have the option of providing tooltips and we're hovering over these individual values, I think it's very useful to think of that in terms of the data to ink ratio. And it's there are obviously UI, their whole field of study on UI and what UI is successful, what UI isn't, user interface is successful or isn't. But really, because we're focusing on data visualization, I think it's more useful for people taking this program to think of it in terms of what they know, and try to really extend these sorts of data visualization concepts. They really do extend to this sort of interactivity. And so I'll let people ask in the chat if anyone has any questions, but otherwise I'll move on to just going over assignment 4, and then we'll finish off the slides that we started last week or 2 weeks ago. So going to module 4, we'll be, and I apologize for, by alphabetical order, module 4.5 shows up all over the place. Module 4.5 should be after 4. So hopefully, I'm hoping people don't get too confused with that, and I'll try to send reminder announcements about that. But so for assignment 4, we're going to be moving on from Shiny and moving into Dash. And Dash is, pretty much, the best way to describe it is the Shiny for Python. So it's, meant to solve a lot of the same problems as Shiny is, but it's slightly different in terms of its structure. It's a bit more low level, so it's a bit closer to, to web development. As you read through and I'll post the link to Dash.plotly, which really is the best way to learn something like Dash. There's, Dash is still relatively new, so there's not really an O'Reilly book on Dash yet, but this documentation is really good as a tutorial, and I would recommend students at their leisure just start going through these parts and begin building toy Dash apps and just build yourself up from there to really get a handle as to how to use something like Dash. And to just sort of highlight a few of the greatest hits here. So it's better to go through all of this, but Dash, it's installable just like any other Python packages. So you're just going to need to pip install your packages. Conda install should work as well. And once you do, you'll be able to get yourself set up with Dash. And what I think is one of the most illustrative, sort of hello world apps is this one right here. So just going to basic Dash callbacks and looking at the first Dash app here. And, what this gives you in terms of, this is pretty much the simplest app you could think of. All it's doing is parroting back what I've entered into this text box here, and gives you an idea as to what's happening with the logic behind Dash. So first you have your layout. In this case, we have just 2 elements. So one thing you'll notice in comparison to something like Shiny is with Dash you're dealing with more raw HTML elements. So you'll see html.div. This is pretty much the same as your div tag, something like that. And in HTML, that's what that would look like, literally. And so really you just put an HTML dot, you uppercase it, and you're able to use those HTML elements. And Chunhui, I'll get to the at symbols in a bit. So basically so to start out with just the layout, one of the first things you'll notice is these HTML elements. So you'll be looking at HTML elements like these. You're able to nest HTML elements amongst each other. So if I think we'll have some. So you could sort of see here how how these elements are being nested in each other. And then W, yeah, you're absolutely right. At is a decorator. It's used in a few places in Python, and I'll show you guys what exactly it's doing. So the so yeah, you're nesting. You're able to nest different elements within within elements. So that's the same as having a div. Within that div, you have a p, a any sort of an a, um, any sort of tags like that, and the you're able to nest it just as just same way that you would with standard HTML. And you have your HTML elements, and then you also have what are called dash core components. So your HTML elements are being brought in here. Your dash core components are being brought in up here. Your dash core components are going to be your interactive elements. So things like drop downs, text boxes, range sliders, your pretty similar to the sorts of widgets you would be able to find in Shiny. And those are defined in the layout here. So you'll see, dcc.input, and in the dash docs, you'll see sort of a full, full exposition of which dash core components are available to you, and those are just included in the layout as other elements. So the first thing we're doing is defining our just defining our app. So it's this dash dot dash object here, and then we're defining our app.layout. And the app.layout is, that's our UI object in Shiny. It's pretty, similar to what you would see there. And then what you're getting to is these callbacks here. So Dan was able to describe what decorators are doing, and he pretty much had it spot on. That what a decorator does is this is literally literally like, so if I had a function called my function, putting a decorator above a function like this is pretty much the same as let me just do this. I'm not supposed to know who I'm working for, but the so basically, if I have the decorators, like having so if I had something like this, so just some pseudocode like this. What this is equivalent to is if I had previously defined hello. So if I had previously defined it like this, and then if I ran so basically what's happening is the decorator is actually pretty much just a function that you're running on a function. And you'll see decorators in Flask, you'll see decorators elsewhere. They're pretty, that it's a pretty common convention across Python. And when you do see it, it's pretty much just this, and it's just a way of making it look prettier. It's rather than having to define your function and having a line being called here, you have your sort of what you're calling on the function. You have your function being defined in the same sort of lines here, and it just makes it that much more readable. So that's what's happening with callbacks. And so what's happening here is, you have a few arguments aside from the function. So in addition to the function, you have this, output and input. One thing to note, input is always a list. So you could have multiple inputs. That's really how you get more sophisticated interactions with Dash. And even if you're including one input, you need to include it as a list. And this is pretty much this callback. And in Dash apps, rather than having one server object, you have multiple callbacks that are based on the output itself. So if I have 12 out, 12, that's a large number, but let's say I did have 12 outputs that I wanted to control, I would have 12 callbacks that are controlling those. And as you're building more and more sophisticated Dash apps, you even get into things like if you have the same object, but you have different properties that you want to control. And actually I didn't really, in the layout, like Shiny, IDs are really how you're referring to all of these elements. So, I have my ID for the input, I have my div for the empty div, and I'm referring to those over here. So I'm essentially returning the children of the div. So the children, that's just going to be what's in between the two div tags. And I'm, with my input, accepting a value from the callback here. But one could imagine, like I've designed apps like this before, where you're changing the style of a component rather than the children. Or the more traditional use case, you're changing a graph, or you're creating a graph when you select, when you make some sort of selection. And here you could see with the callback, rather than having children, we're having figure. So, what this is saying is with each change in the input, or one of the inputs, you have a list of inputs, we are making a change to the figure of the output here. And so that's how you end up with apps like this. And I think I'll leave it there because it's very useful to go through these at your own leisure. And but those are are really the most explanatory apps, in my opinion. That sort of will help sort of ease the transition into learning Dash. So any questions? And then so if anyone has any questions on that, type it in the chat. And then so then to finish off talking about assignment 4, I have some sample code here. And so what we're doing with the with the actual module itself is we're looking at data from the New York City tree census. And this is a really cool data set that I am not able to click onto there. So I'll click onto it here. So this is a really cool data set. It's coming from a service called Socrata, if anyone has come across that. They are a company that manages a lot of the open data efforts for various governments and organizations. So they're a name that comes up quite frequently if you're dealing with open data. Going to portals like this, going to government portals, and checking out Socrata themselves, like that's a pretty good way of finding data sets that might be interesting for a final project. So this is also meant to help give people some other options as to what they could find there. So the point of assignment 4 is both to introduce Dash and to get people a bit more thinking a bit more critically about the sorts of apps that you would be building, that you would be building, sorts of data products that this course is really preparing you to build. And so you have an API And we're asking these two questions. So what proportion of the trees are in good, fair, or poor health according to the health variable? And we have this other variable called steward. And are these stewards having an impact on the health of trees? So whenever you're looking at these sorts of open data sets, a lot of portals, they'll have pages like this where you have descriptions of various columns. You can see 45 here. You'll have some sort of preview as to what this looks like. So this is a pretty cool data set. You have pretty much every this is aiming to log every tree in New York City. And actually, for those who live in New York City, I don't know if they're still doing it, but this was actually largely run by a volunteer effort. So if you have you could volunteer yourself if you want to begin cataloging trees in your neighborhood if that's something that interests you. So you have like a data point for each tree, and you have several you have lots of different variables. So all your variables could be described here, and this is really meant to sort of give people an idea of, you have this API, you have a wealth of information there, but how are you going to bring this information into an app? And so in this sample code, this goes through a few quirks of using the Socrata API. So first what we tried to do was we just naively in each of these links, each of these portals, they come with a link, so you're able to copy the JSON right here. And I'm just naively reading in the JSON. So just pd pandas read JSON, the URL, and I get something. So this is good. I'm at least getting it looks like I'm getting all of my columns, and I at least am getting something. But when you take a look at the shape, you could see we're having we only have 1,000 trees, and while New York is a concrete jungle, there's probably more than 1,000 trees in New York City. So it's and as I mentioned, it's a suspiciously round number. So what might be going on here? And what's actually happening is Socrata places limits on their API. And this makes sense if you think about how an API like this is meant to be used. So imagine just simply a web app that's displaying tabular data of these trees. One of the things that might be an issue is you don't want to load up all however many trees are in the data set. Should give us how many out of the 648,000 trees. You might not want to. It would almost definitely be a bad idea to display all of that on one page. But so what this really does, is meant to mimic is what this would really look like being used in the real world. So you have essentially these limits and offsets placed on the API. So if I wanted to show 5 results, for example, I could do that. If I wanted to design like an app that pages through these results 5 at a time, I would essentially be building my API URLs like so. So I would have, be changing my offset. In this case, the offset is 5. In this case, the offset is 0. That's the only thing that's changing. So by incrementing the offset by 5, I would be able to, essentially page through the results, utilizing the API dynamically. And Socrata has a documentation on on what paging is supposed to do. You'll also find in the docs here some more complex things. So here in particular, you'll see what's called SOQL, or Socrata SQL, however you want to pronounce that. And these are, I included some examples in the code over here. But basically, these should be reminding you of SQL. So it's not exactly the same. You're building a URL, but you could sort of see what's happening here. So I sort of am dividing up the URL, so that's a bit more apparent. I like doing that when I'm building apps like this. But you basically have your select. So select select two columns. So select species column and count of tree ID, where the borough name equals the Bronx, and we're grouping by the common name of the species. So this is just giving us the count of each species of tree in the Bronx. And once I do that, I get a more trustworthy table. You can see I have 132 two rows and 132 records, one for each unique type of tree. And I'm able to get an idea of the number of trees. And this is going to, you're going to need to use these sorts of methods in order to build your app. So, this is an example of what you're doing here, and this is very, common with using, APIs like this. You have to, like web APIs are meant to be used by web apps. Web apps aren't really, and when you're working in RStudio in a Jupyter notebook, you're really used to strong arming the data. You're used to, I just want to bring in the whole CSV and, do whatever I need to in memory, assuming you don't need to do, assuming it's not billions of rows. And, you'll be pretty successful in working with it that way. So here, you're able to, you'll be needing to do this to build your web apps. So any questions on that before we just get into a web app thought experiment? And if your microphone's working, feel free to speak up. Otherwise, I'll just keep an eye out. I'll keep an eye on the chat if anyone asks any questions. So, we last left this off with our lecture 2 weeks ago, and what I really wanted to try to guide everyone through was sort of a thought experiment on what sorts of things you need to think about when building a web app. So something like Leaflet is an open source JavaScript library which lets you create custom tiled maps. So it lets you, pretty much create, custom like Google Map style maps. So if I go to the Leaflet page, you could pretty easily have your underlying, map here have a sort of tooltip coming up with a point, and it's not even that much JavaScript that's going into that. So Leaflet lets you pretty easily build stuff like this. And then Datashader, we all remember Datashader from 2 weeks ago from Module 2. And in particular, what I want people to key in on is Datashader. What Datashader shows you depends on the canvas. So does anyone remember, what sort of and actually before I do that, we'll just sort of talk about the sort of goal here. So what we're going to imagine is, something like Datashader. You have a canvas. This image updates in an intelligent way depending on what your canvas is, and that lends itself pretty nicely to something like this. You can imagine this is nothing but these tiles below. This is nothing but an image. When I zoom in, it changes what that image is. When I zoom out, it again changes what that image is. And that's it's very comparable to what you're doing with Datashader. You're providing a canvas, you re-render the image based on what that canvas is. And this could be a pretty cool way of exploring large data sets. Like imagine if this, instead of being a map, were a large data visualization, and I were able to zoom into areas of interest, have the graph re-render as I zoomed in, and sort of have the app exploration work that way. And just one warning here, this hasn't actually been, or I haven't tried it out and I haven't found it out there. It's so there could definitely be things I'm missing here, but this is really meant to have to get people thinking. So the first question to ask is, what exactly does a Slippy map do when a user interacts with it? So does anyone want to put in the chat, like, and in particular, another way of asking this question is, what are the variables that define the state of a map? So when I'm looking at a map like this, what sorts of variables make this different than this, and different than this? What sorts of variables are? So Brian mentioned longitude and latitude. That's absolutely one of them. And there's one more that, yep, and Vikas, you got it. It's the current coordinates, so the current center point, and the current resolution. So you have this sort of zoom in and zoom out behavior. So the other question is, how can Datashader be used to complement these needs? So when you do have something like Datashader, when you're using your canvas could pretty much be translated to it's not directly one-to-one, but part of what you'd be doing in designing an app like this is sort of having a user input being a center, a sort of a center point, coordinates, a zoom, current resolution, and have that result in something